So in this video, we're asked how we can turn this alpha-beta unsaturated ketone into this nice little ketone product here, right? It's the same cyclohexane ring, but we have an ethyl group here and a methyl group here. This is gonna require some very careful chemistry. And if you look at the alpha-beta unsaturated ketone, you're probably thinking already the alpha-beta addition, also known as the Micheal addition. So we're actually going to be doing that here. Let's start with our starting material. And I'm going to ask myself, how can I add an ethyl group and then a methyl group, or a methyl group then an ethyl group? Well, I know with Micheal reactions that it's going to add beta. It's the best position to do so, right? Because if we attack this center here, we're going to make an enolate, and that's resonance stabilized, where if we attack this and put a negative charge here, it's just a carbon with a negative charge. That's not very good. So let's go ahead and devise a synthesis. Well, I know that if I attack here with a Micheal reaction, it's going to kick electrons here. I could use then an electrophile of ethyl, maybe like an ethyl iodide or something, and I could get our product. So that's exactly the logic I'm going to use. And if you don't see it now, I'm going to draw it out and you'll see it. So I'm going to use, and you could use all sorts of Micheal reagents, right? But most of them are those resonance stabilized, like anhydride looking things, but we don't want those here. We want the Gilman reagent. We remember that's another form of the Micheal, I believe it's the Micheal acceptor. Alrighty, well, let's draw it here. So we have methyl, copper, methyl, and then we have that lithium spectator ion, right? That negative charge makes this bond very polar, and that methyl group, there's no mechanism for it, but it just gets added on. And this is a synthesis anyways. Who wants mechanisms when we have syntheses? Okay, so basically what happens is we get the methyl group here and we get a negative charge here. Okie dokie. So we have that there. And how do we attack this negative charge? Well, this is now an enol, right? If you remember with that alpha alkylation, we're kind of going to see an analogous thing. But instead of LDA that we just used a Gilman reagent, and we put the negative charge here, right? So same process that LDA would do, but we added that methyl group by using the Gilman. Okay, so all we have to do now is use an alkyl halide, and it will do backside attack, right? Electrophile species, nucleophile species, and we get an iodide leaving group. And what we notice is, well, we're gonna get our product. Kind of cool, isn't it? This reaction, it's a very specific one. If you start with this, you have to do just the right reactions to get this product here. That's exactly what we do. Hope you enjoyed. If you did, please drop a like, subscribe, comment if you have any questions, and have a wonderful day.